problem of the optimization problem. This problem is the poster problem. Okay, let me just write it down. Some people may not have it. So the situation for the poster problem is this one. So this is going to be number one, and this is poster problem. So in this problem, the margin of the top and the bottom would be given to you. So we have a poster, okay, to have an area of 180 square centimeters. Okay, so this is going to be a situation I'm going to have. So get a poster. So this is going to be a poster. Okay, then you get the margin to the top and the bottom. So this is going to be this is going to be the printed part, if you like. The printed part, you read it carefully. So this problem is a little bit different. A poster, let me write it down because this is kind of a little bit different from what we did. So this is it. A poster is to have the poster is to have an area, okay, an area of 180 square centimeters with margin with 1 centimeter margins. Okay, centimeter margins at the top and the side at the bottom. At the bottom. Okay, at the bottom and sides. And sides. And the margins are a little bit different. And a 2 centimeter margin. And 2 centimeter margin. Okay, at the top. At the top. So this is a situation that we're going to have. Okay, so we get a poster over here. So what's the question? The question is going to be, this is different from what we did. We want to know what the dimension. Okay, you want to use it as a printed paper, if you like. So you want to know, you make a best of your paper. So we want to know what the dimensions will give. Okay, dimension will give the largest okay, largest printed area. This is the kind of opposite of the one that we did, printed area. Okay, read it carefully to see what is given to you and what you are looking for. In this problem, the one that we did, we give you the area problem, the printed part. But in this problem, the area of the poster is given to you. So this is going to be the red one is going to be the poster. The blue one is going to be the printed part. So you identify the margin. The margin that you have is 1 centimeters down the bottom. Okay, so this is the margin down the bottom is just 1 centimeters, and the sides. So to the right, to the left, they are all 1 centimeters. Okay, but the margin on the top is 2 centimeters. This graph is not a good one, but this margin over here is going to be 2 centimeters. Okay, so this is the situation I'm going to have. Now, what you know is an area of a poster. You see, a poster is to have the area. So the area of the poster is given to you. So the area of the poster is the red one. Okay, area of the poster. So the area of the poster is 180 square centimeters. Okay, so what you would like to use it as a printed paper, but you would like to make a best of it. So we want to know which dimension of the poster would give you the largest possible area for this part. Okay, so you want to find this dimension, so that the area of the largest part, area of the printed part, is going to be a maximum. The one that we did, the printed part was given to you. Just make sure that which number is given to you and just go for it. As we talk about it, you have to pick two variables, x and the y. So for both problems, you pick the x and the y to be the dimension of the given one. The dimension of the given one, because that's make it easy for you to operate it. The area of the given one is area of the poster. So what you're going to do, you're going to pick the x and the y to be exactly what you are looking for. Okay, so for the solution, so what we are going to do is we are going to get this. I just put it over here so that you know what I'm doing. You see, so you have to pick this one to be x and the y. So this is missing. Why? Because as soon as you pick the x and the y over here, you know that this area is already given to you. So you know that the x times y is equal to the 180, and then that enable you to find the y, which is going to be 180 over x. Okay, so you just check to see which part that's given to you. Just pick this number for this. Then you have to connect it with the blue one. So this is going to be 180. So what you would like to do is you would like to maximize the inside one. So what's going to be the area of the printed part? You see the area of the printed part, area of printed part, if you like, is equal to what? You see this big one is equal to the x. The red one is equal to the x. You want to find the blue one. So look at the margin that you have. The margin to the right over here is 1 centimeter. And the margin to the left over here is 1 centimeter. So the big one is x. So what is going to be the smaller one? Any suggestion in terms of the x? If this is x and the margin to the right is 1 and the margin to the left is 1, so what is going to be this blue part in terms of the x? Any suggestion? Yes. The big one is x. So in order to get the blue one, the smaller one, you have to take out. What are you taking out of the x to get the blue one? It's going to be margin to the right, 1 centimeter, margin to the left, 1 centimeter. So this means this is going to be x minus 2. The one that we did the other day was the other way around. Okay, so the big one is x. You want to find the smaller one. So the smaller one is the big x minus what? Minus margin to the right, margin to the left, which is x minus 2. So that's going to be x minus 2. Now, how about this one part? This one? The big one is y. What is the margin to the top and the bottom? Remember the margin to the top. The margin to the top is 2 centimeters. The margin down the bottom is 1 centimeter. So in order to get the blue part over here, we're going to take out something out of the y. What are we going to taking care of the taking out of the y? The margin at the top, 2 centimeters. The margin of the bottom, 1 centimeter. So this portion over here, you see this one, is going to be what? Is going to be y minus 3. So the area of the printed part is going to be the product of x minus 2 times y minus 3. This is how you set up this problem. This is from your book. There are different ways to do it. You can go with the x and the y inside, which is not going to be a good one, because you have to have a relationship between x and the y to be able to operate this problem. Okay, now we are ready to set up that. So this is the quantity that you want to maximize. So what you would like to do is you would like to find the x and the y so that x minus 2 times y minus 3 to be a maximum. You know that the quantity that you want to maximize or minimize, this is the one that you are going to call it a function. And then you are going to use derivative of the function to find the maximum over here. Okay, so the problem starts from here that you introduce a function. Okay, so your function is going to be f of x. F of x equal to what? Is equal to the x minus 2 times y minus 3. But quickly, you say f of x, but you have x and y. Quickly, you have to bring the y. But where is the y? Y is 180 over x. Okay, so we say, oh, note that y is equal to the 180 over x. So substitute here. So your f of x is going to be equal to the x minus 2 times y. Y is 180 over x minus 3. You see, this is going to be your function. You have to FOIL it. Okay, use FOIL method to simplify it, and then you're going to start working with the derivative of the function. So FOIL method, f of x is equal to, you multiply the x, you know this is how you do the FOIL. This is it. So if you multiply these two together, x would cancel out to get 180. You move forward, x times negative 3 would be minus 3x. Then you go inside and you continue. You see, you multiply the 2 by this 2. So 2 times 180 would be, this is going to be minus 360. Okay, 360 over x. And then negative would be positive, so that gives a positive 6. You combine the like terms, 180 and 6 and 1. So it's going to be f of x equal to the 186. Okay, minus 3x minus 360 over x, with the condition that the x to be positive because the x is a dimension. This is going to be the function that you have to provide to be able to continue to do the job. Any question? So it's important to set up that first part, the relationship between those printed area and the poster. So from now on, we want to maximize this because you are interested in the dimension of the poster so that the printed area would be a maximum. It's a function. So in order to find the maximum, you know that you have to differentiate it, find the critical points, then test it, and then you get the result. Since you want to differentiate it, I suggest to move this x up because you have to differentiate it twice. Okay, so this is going to be, I'll go to the next page to continue this one. Any question? So get the graph of the information and then you'll be able to do it. So I'm going to go to the other side to continue with this. Okay, so I move the x up. So my function is going to be f of x is equal to the 186. Okay, that would be 186 minus 3x. Okay, minus 3x, and this is that was minus again. Okay, 360 over x over x. So I just bring it here so I can repeat it. So this is going to be equal to the 186 minus 3x minus 360x to the negative 1. Now differentiate it. So f prime of x is going to be equal to derivative of 186 would be 0. Derivative of negative 3x would be negative 3. Okay, and this is 360. Negative would be positive, so that give a positive 360, but x goes to x to the negative 2 because we differentiate it. Okay, so this is going to be the derivative. Let it equal to the 0. Okay, f prime of x equal to the 0. then it's going to be -3 plus, I change this one into the 360 over x squared equal to the 0. Okay, we have to solve this equation. You have to get rid of the x squared. One way to do it, you can multiply both sides by x squared, or you can move it to the other side and do the cross multiplication, which is easier. So it's going to be -3 equal to the -360 over x squared. You see this negative would be out, cross multiply. So that gives you 3x squared equal to the 360. Okay, and then you divide by 3. So x squared would be 120. 120, so your x would be a positive negative square root of 120, but x is positive. Since x is positive, so your solution is going to be x equal to the square root of 120. Okay, you can use your calculator to find it. If you want to keep it, you have to simplify it. Okay, 12 is going to be 4 times 3. If you want to keep it as is, you better use your calculator to estimate this one. Okay, so it's a square root of, okay, a square root of 120. So it's going to be, okay, and this is, so it's going to be almost 9.995, 10.95. So it's going to be almost 10.95 centimeters. Okay, so this is going to be your x. Okay, so x is going to be 10.95 square centimeters, almost 11. Okay, and so this is going to be your x, but you have to test it because you are looking for a maximum. So how do you know that you get a maximum? For the testing, of course, we use the second derivative test because the first derivative is easily given to you. So it's going to be f prime of x, which is equal to the -3 plus 360 x to the -2. You differentiate it again. You see f double prime of x is going to be equal to this would be 0. And you just multiply again. So it's going to be minus 720 x to the -3. And if you rewrite it, that gives you 720 over x cubed. Remember, the x is a positive number, so this is always negative. F double prime negative means it's going to be concave down. Concave down means you are going to have a maximum. So be sure that f has a maximum. You have to test it. F has a max at x equal to 10.95. Okay, now that we're sure that we have this one, we go back and find the y. So what is going to be the y? Y is equal to, remember, y is equal to the 360. Y is equal to that was the one, sorry, 180. Y is equal to I repeat it here. So y is equal to the 180 over x. And this is going to be 180 over x. Okay, you can write 10.95 or just the square that we did. So it's going to be 10.95. Then you are going to use calculator to get this result too. So this is going to be 180 and divided by 10.95. So the result would be something like 16.43. So 16.34 centimeters. So the dimension of the poster are going to be x is equal to okay, so the final answer, the dimension of the poster, x is equal to the 10.95 centimeters, and the y is equal to the 16.34 centimeters, and that gives you the final answer. Okay, that's the best problem that you have in the case of the poster problem. So if you pay attention, there are two possibilities, and we give you both of them. You have one of them in your lecture notes, okay, that we did it the other day. And this one was different. What is the difference between these two? And this one is going to be different because as I talk about it, just read it carefully. You see the area of the poster was given to you. The one that we did the other day, the area of the inside one was given. But the rules is, if you want to do it, you have to pick the X and the Y to be close to the given number. So I picked the X and the Y to be dimension of the poster. Why? Because that gave me X times Y equal to the 180. That's easier. If the printed area is given to you, you get this dimension of the printed one to be X and the Y. If you do it from this part, when you want to find the area of the poster, you have to take the margin out. If you do it the other way around, you are going to add the margins as we did over there, okay? So that is going to be choice one, poster problem. You have 3 in your assignments. You can pick one of them just to practice. Okay, any question? So this is one possibility. The problem number 2 is everyday life problem, okay? So that's the one that, you sell something, you want to attract more customers, so you have to give them some discount. Okay, so in this case, the problem is, I write it down. In this problem, a business selling a TV, okay, flat screen TV sets, and then they want to make more money. Okay, so this is it, a business or a manufacturer. Okay, a manufacturer has been selling, okay, has been selling flat TV screen, okay, selling 1,000, okay, 1,000 flat screen TVs, television, okay, a week, per week, at the price of $450 each. You see, that's the beginning of these type of problems. So the business selling 1,000 flat screen TVs at the price of $450. So at the end of the week, what is going to be the revenue of the shop? Any suggestion? Selling 1,000 TVs at the price of $450 each. So what's going to be the total price or total revenue? Any suggestion? Price of one TV is $450. You have how many TVs? 1,000. So in order to get the price of all of them, you multiply both of them together. So at the end of the week, the business make $450,000 for selling these TV sets, okay? So remember the revenue. The revenue is always the product of the number of the items, times the price of one items. Now, this business would like to make more money. So in order to make more money, they are going to reduce the price, okay? Offering some incentive. So we investigate and we find out a market. Okay, a market survey. This market survey indicates that for each okay, discount, for each $10 rebate, for each $10 rebate means if you lower the price by $10, then they get more customers. Okay, rebate offered. Okay, rebate offered to the buyer okay, to the buyer, we get the more customer. The number of the, okay, the number of the TVs, the number that we're going to sell are going to be more. Sold will increase. Okay, will increase by how many? Okay, will be increased by 100 per week. Okay, so if you lower the price by $10, you see original price was $450. So if you lower it by $10, you are going to have 100 more customers. Remember, you used to have 1,000. But if you lower it by another $10, then you get 100 more. Okay, so we want to know how far are going to go to sell the TVs, but you make a maximum revenue. Okay, so how much the price? So we want to know how much the company, okay, how much the company or the business should charge, or how much should the company should charge the customers, the buyer, in order to maximize. Okay, maximize their weekly revenue. Okay, it's called revenue problem. And it's very popular and easy to organize. So, so it depends how many times are going to offering that $10. For this type of problems, you see, originally, as I talk about it, original revenue is 1,000 times 450. So the revenue is, I just remind you again, you see, this is how we collect the revenue. The only thing that we have to know, revenue is equal to the number of items that you sell, number of items, times it by price of each, okay, price of each unit or item, each item. That's the revenue. Originally is 1,000 times 450, but you are going to have a new revenue if you like. So new revenue depends how many times are going to offer the rebate. For this type of problems, you have to set an X. Okay, you are going to suppose X in this problem is going to be, X is what? X is a number of the time that you're going to offering that $10. Okay, so X is going to be number of, let's say $10 offered rebate. Okay, rebate that, that offered. So it's always the case. Now we are going to check this revenue again. So we call it R of X to be your, this is R of X is going to be your new revenue. Now we're going to collect this revenue. See, exactly the same as the one that you got over here. So R of X is going to be equal to, now new number of the items. I write it down just for your information. New number of items when you're offering that $10, times it by new number of item. I'm sorry, new number of the items times new price unit, price per item. Okay, when you're offering this, so the revenue would be changed. So this means what is going to be R of X is equal to new number of the items. You check to see what's going to be the original number. Originally, you're selling what? 100 TV. So originally it's 100. So when you offer the rebate, this number is increased. So this means that the number would increase, means it's going to be plus. How many TVs? You see, when you offer the $10 rebate, you get 100 more customers. So it's going to be 1,000 plus 100. But how many times do you offer it? X number of the time. So 100X. So this is going to be new number of the items. Any question? So you have to set this up, correctly. If they say it's decreased, so you get a negative here. So original number 100 TVs, you get more customers, you're selling more means plus. How many more? 100. How many times? X number of the time. So this is going to be number of the item that you're going to sell when you're offering that rebate times new price. So what was the original price? You see, for the new price, original price was $450. You see, originally you're selling $450, price of each TV. But what did? You reduce the price. Reduce means minus. By how much did you reduce it? You reduce it by $10. How many times are going to do it? X number of the times. You see, this is going to be a function. So make sure that these numbers are on the proper place. This is dollars, and this is numbers. So original number 1,000, you increase it by 100. Anytime you offer the rebate, how many times are going to offer in the rebate? X number of the time. Okay, so that would be 1,000 plus 100X. Now the price. Original price is $450, but you reduce the price. You reduce the price how much? $10. How many times? X number of the time. This is your function. The restriction is X is positive. That's it. You FOIL it, you get a function, but you want to maximize it because you are interested in maximum revenue. So you have to differentiate it, get a critical number, and then get the result. Okay, any question? So carefully FOIL this one. So sometimes they switch this, you may offer, you may increase the price. If you increase the price, you may lose customers. So this would be negative, this would be positive. So you read the problem carefully. Anytime they say more, it's a plus. Anytime it's reduction, it's a negative, okay? So FOIL this one and then differentiate it. When we R of X equal to multiply, go forward. So that give you 450,000. Okay, we go forward here. So that gives us minus 10,000. 10,000X, you go inside, you multiply this two, is going to be 445,000 X, and you multiply these two together, that give you minus 1,000 X squared. Okay, combine the like terms because there is a case here, and you have to simplify it. So your function R of X is going to be equal to the $450,000. Okay, that's a 10,045. So that give you a plus 35. Okay, 35,000X. And this would be minus, minus 1,000X squared. This is your function. Okay, you want to maximize it. Now the calculus part. Differentiate it. R prime of X is going to be equal to a derivative of $450,000 would be 0. This would be 35,000. And 2 times 1,000 is going to be 2,000. So that would be 2,000X. This is the derivative. Any question? Let it equal to the 0 because you are interested in critical value. So we let it equal to the 0. If you let it equal to the 0, you have a 35,000 minus 2,000X equal to the 0. solve for x, so that you have negative 2000x equal to the negative 35,000. So your x would be 35 over 2. So it's going to be 35,000. 2000 is going to be 35 over 2, which is 17.5. Okay, so it's a kind of critical value for your function. 17. This is the number of the time that you're going to reduce the price. But you have to test it to show that this is a maximum. Remember, if you don't test it, your problem is not going to be valid. So testing, of course, the second derivative test. So for the second derivative test, you have to bring the second derivative. This is the first derivative. So if you differentiate it again, you see r double prime. If you differentiate it again, so r double prime of x would be what? Derivative of the 35,000 would be 0. So that would be negative 2,000. But this is negative. A second derivative negative means it's concave done. And concave done give you a maximum. So you confirm that the revenue would be maximum. R of x has a max. A max. Okay, a maximum at x equal to the 17.5. So if you go this far, you are sure that you are going to get a maximum revenue. But they ask for the price only. What price give you this one? You see, that's a new price that we have. What is the new price? Remember, original price was 450. So it's minus 10x. So the price that to make it maximum price is originally $450 minus 10x. So it's going to be 450 minus 10 times 17.5. So the price in dollars is going to be 450 minus 175. Okay, that's a 5. So the result is going to be what? It's a 5, 7, okay, 275. So the price that give you the maximum revenue in dollars is going to be $275. So if you offer this price to the customers, you are going to make lots of money. If you want to find the maximum revenue, of course, you drop 17.5 into the revenue function. But we are interested in the price only to get this, this true. Okay, any question? So that's again a very nice problem. It's a very common problem in everyday life. You offer the discounts, okay. Sometimes you increase the price, you will lose customers. But sometimes, as this one, you offer something good, incentive, so you're going to attract more customers. Okay, so that is the revenue problem. Any question? So the theme of this problem really is this formula. You see the revenue. The revenue is always number of the items times the price. In all these problems, get the x, then the number of the action that you take. Your action is going to be increasing price or decreasing price, depends. Okay, then form the new revenue. The new revenue would be new number of the items and the new price. New number of the items start with the given one. The given one was 1,000 item. If it's more, plus. How many? 100. How many times? X, 100x. Price, $450. You reduce it. How much? $10. How many times? X number of the times. So that's going to be item price. The rest are going to be calculus. Carefully, you simplify your function. You differentiate it to get the critical value, but you have to test it. You test to see that in this case, you are going to have a maximum. If you find out that you have a maximum, then you go back and find the price. Originally 450, you reduce it by 10x. So the price, they should set the price at 2000 and okay, that's it. Yes, at $275. That gives us the maximum. Okay, so that's going to be the second case. Any question? So we are mostly interested in these two parts, but there is an abstract one because the function in this abstract one is the same as the others. But since on this quiz we give you two, so you have to read it carefully because in the test we give you only one of these. Okay, so the abstract one. Any question? So this is just to setting up the problem, nothing to do with the everyday life. So that's a famous Fermat problem that we investigated, but I just, there is a point which makes this one different from one we did. We would like to find the two numbers, two positive numbers that let's see which one is it. I write it down. This is the case that the product of the numbers are given. You want to minimize the kind of sum. So find the two positive numbers. That's a third case. Find two positive numbers. Again, this is a little bit different from one that I did the other day, but you have it in your book. Such that the sum, okay, the sum of the first number, the sum of the first number, the sum of the first number, and look at this one, this is different, and 4 times the second one, and 4 times the second number. The second number okay, so that's it. Find the two positive numbers such that the sum of the first number and 4 times the second number is 1000. Okay, so this is given to you, and the product. Okay, the product of the numbers is as large as possible, is a maximum, is as large as possible. It's very much like the one that we did. The one that we did, it was sum of two numbers was 1000. In this problem is a sum of the first number and the 4 times the second one. So not a big deal. Okay, you have to change it to the symbolic form. So you want to find two numbers, you call them X and Y. The sum of the first and the 4 times the second 1000 means X plus 4Y equal to 1000. You want to find these two numbers so that the product to be a maximum. So this is how you set up this problem. Again, we would like to have something from everyday life rather than just something just abstract. So this is how you are going to set up this problem. You are going to pick X and the Y for your numbers. So suppose X and Y are going to be, okay, are going to be positive numbers such that the given information. You see sum of the first X plus 4 times the second 4Y is 1000. Okay, and you would like their product X times Y is going to be a maximum. So this is what you are looking for. Quantity that you want to maximize is X times Y. Remember, this is the quantity that you are going to call it function. So you pick your function to be x times y. As usual, it must be a function of one variable. Then you have to find the y from here and just substitute, get the result. Okay. So you define the function. So define, or suppose the function is this one. You have to give us a function f of x to be equal to the x times y. But you cannot have x times y because your function is a function of x. So go and find the y here. So we say, note that I have x plus 4y equal to the 1000. Solve for y. So that gives you 4y equal to the 1000 minus x. Divide by 4 to get the y. So y is equal to 1000 divided by 4 minus x divided by 4. Okay, 1000 divided by 4, that give you 250. And that would be x over 4. You can write down a quarter of x. This is your y. Now go back, substitute here, then you have a function. So your function f of x is x times y. So x times y becomes x times 250 minus a quarter of x. You multiply it, simplify it. So f of x is equal to the 250x minus a quarter of x squared. This is your function with the restriction that the x is positive. You see, this is how you set up the function for this problem. Just a Fermat problem, we did x plus y. We talk about the perimeter of a rectangle when we did this one, and x times y was the product. So that was the area, but this is a very much an abstract problem. Okay, you want to maximize it, bring the calculus now, differentiate, let it equal to the 0, get the critical value, test it, and then you're done. So we differentiate it. The derivative of 250x would be just 250. The derivative of x squared, so that we minus, that's it. This is going to be a quarter times 2x differentiated. You simplify the 2 and the 4, so this is going to be 250 minus 1/2 x. This is your derivative. Okay, let it equal to the 0 to get the x. So we let it equal to the 0. So we solve for x, it's going to be 250 equal to the 1/2 x. Cross multiply. So that gives 2 times 250, which is going to be 500, equal to the x. So your x would be 500, which is going to be the critical value of this function. Okay, any question? You have to test it. And the second derivative test. Remember, all these problems must be tested. Testing, second derivative test. This is f prime. Bring the f double prime. So if you take f double prime, derivative of 250 would be 0, derivative would be negative 1/2, which is negative. F double prime negative means you have concave done. So the concave done will give you a maximum. Okay, so we confirm that our problem would have a solution. Okay, always you have to get the confirmation. So f has a max. Okay, f has a maximum at x equal to the 500. And you need x and y, so the y. So go into this relationship to get the y. So what's going to be y? Y would be 250 minus a quarter of 500. Okay, we got the x over here, and that is going to be the case. Okay, so 500 divided by 4 would be 125. So y is going to be 250 minus 125, which is 125. So the final answer for those two numbers, x equal to the 500 and y equal to the 125. That give you, the product are going to be a maximum if we get x equal to 500 and y equal to 125. This is the kind of problem that you did in college algebra, because this function is a parabola. But we just want to confirm it with application in calculus. But as you can see, the other two was more interesting, and we are going to be interested in those type of problems. Okay, so we create a situation from everyday life, postal problems, revenue problem, so that you design the problem. But it's also a case, and nothing to worry about. Okay, so this is the optimization problem part. Any question? So one for your next test next week. Okay, the next week at the week on Monday. But two on this quiz, two of these optimization problem. Okay, so that's the first topic that we're going to have. Our next topic are going to be more interesting. Okay, all of them are interesting, of course, but for future, and that is going to be limit at infinity. We talk about it. If you want to take calculus 2, that's going to be the one that you need. And we give you a very easy method to find it. The method is that we usually use in even for computer science. I told about the Pico notation, but over here, easy. So there are 3 groups of problem for the limit at infinity. Okay, so that will take us into the problem number, this would be number 4. Okay, number 4, quite a lot here. We usually give you 1, 2 parts of this limit. So we want to find each limit. Find each limit. So the concept is limits at infinity. Limits at infinity. It's the one that we did. The cases are, we talk about it. Limit at infinity means x increases without bound, x getting bigger and bigger, x goes to positive infinity, or x getting smaller and smaller, x goes to negative infinity. The idea that we use is the power function. We talk about it that if you consider a polynomial, the limit of the polynomial at infinity is the same as the limit of its leading term. Leading term is the term that contains the highest degree of x. So we're just shrinking these limits into the polynomials, and then we do the job. Okay, very nice method for future. There you are. So there are going to be 2 groups, okay, of the problems that we are going to have. Okay, so the first one, the part 1. Part 1 is the limit of 2x plus 5. Okay, 2x plus 5 over x plus 1 when x goes to positive infinity. If you write infinity, we mean positive infinity. Okay, that's it. We talk about it. It's a polynomial types. We shrink it. The top is a polynomial. The limit would be the same as the limit of the 2x. The bottom one is a polynomial. The limit would be the same as the limit of the x. But it's important the way you write it down. This is it. Limit of 2x plus 5 over x plus 1. When x goes to negative positive infinity is the same as the limit of, you see, leading term. See the leading term? This is the leading term. So the limit of the 2x over x, x goes to infinity or the positive infinity. So the x and x would cancel out. The answer would be 2, and you're done. Any question? We call it type 1 because the degree of the top and the bottom are the same. If the degree of the top and the bottom are going to be the same, the short one is the ratio of their coefficients. You see the coefficient of the top is 2. The coefficient of the bottom is 1. 2 over 1, which is 2. Or just shrink it, you get the final answer and you're done. Any question? This is the only method that we accepted on the test, remember. There is another method, they call it the Lobter rule. We talk about that one at the end of the course. So you have to use this one only. Okay, there are 3 possibilities for this case. So it depends on the degree of the top and the bottom. So this is it, 3 minus 2x squared divided by 3x squared minus 1. And this time x goes to negative infinity. Again, polynomial on the top, then the bottom, leading term. This doesn't mean that the first term. Leading means the one with the highest power of the x. So the leading term on the top is negative 2x squared. Then the bottom is 3x squared. So this limit would be equal to, this is the way you write it down. So originally is a 3 minus 2x squared over 3x squared minus 1. X goes to negative infinity. So it's going to be the limit of x goes to negative infinity. The leading term on the top, negative 2x squared. Down the bottom, 3x squared. So x squared and x squared would cancel out. You get negative 2/3, the final answer. Any question? Remember, if you don't write this limit, you won't get any point for it because the limits are the same, not the function. Be careful. Any question? You know, we use it in calculus 2 and even we use it in calculus 3 quite a lot. So that was just to explain it to you that leading term means the term containing the highest power of the x. Okay, case C. The case C is the limit of this function, limit of x squared plus 1, okay, divided by x cubed minus 1. X goes to infinity, which is the same as positive infinity. Again, you see the difference between this problem and the other one are going to be the one that the power of the bottom is higher. We talk about it when the power of the bottom is higher, there's going to be infinity down the denominator, the leftover. And that make the denominator huge. So the fraction would be tiny one. So the limit would be 0. But we can just continue with the method that we have. These are going to be the leading term. So the solution is going to be, so we go with the leading term. Again, we rewrite it. The limit of x squared plus 1, x cubed minus 1, x goes to infinity is the same as the leading term, limit of x squared on the top, x cubed on the bottom, x goes to infinity. You simplify it first, you see, there's going to be an x squared, it give you 1, that give you x. So it's going to be limit of 1 over x. X goes to infinity. We talk about it, that's a pizza problem. The top is a pizza, 1. Bottom, infinity. So this means you have a pizza, you want to divide it by infinite, infinity. So you want to have infinity many parts of a pizza. So your share would be nothing. So this is always 0. Okay, we call it pizza problem, or just, you understand. The top is fixed, but the denominator getting bigger and bigger and bigger. So when the denominator is getting bigger and bigger and bigger, the fraction getting smaller and smaller and smaller. So the result is 0. Some people like to memorize. They say a number divided by infinity is 0. Okay. If you feel comfortable to remember it, we don't mind. But basically the idea is there is a leftover down the denominator, a big one, infinity. So that would be 0. Okay. So in future, as soon as you say 0, we accept it. So the degree of the bottom is higher. So this is 0. Okay, that's it. Because there is going to be a leftover. You see, in this problem, when you cancel it out, there is not going to be leftover. It's all numbers. But when the degree of the bottom is higher, x is there, so infinity is here. So the result would be 0. Okay, any question? We have one more possibility of this case 1. So part D. So degree, the bottom was higher, degree is the same. So you need one in which the degree of the top is going to be higher. And this is part D. So the part D is the limit. Okay, it's going to be the limit of x goes to negative infinity. And the rational function is x to the 5th plus 2 on the top, okay, and x minus 1 down the bottom. Again, you see degree of the top is higher. So the infinity is up there. So this limit would be infinity. It may be positive or negative, depends on the power that you're going to have, okay? Just for future, but now, again, shrink it to its leading term and investigate it. So the solution is going to be, so we have the limit of x to the 5th plus 2 over x minus 1. X goes to negative infinity. So now this is going to be equal to the limit of, you shrink it into the x to the 5th, x goes to negative infinity. Now we simplify it, the bottom one would be 1, but the top, the leftover would be x to the 4th. So it's going to be limit of x to the 4th. It's a power function, you know that. Result is a positive or negative infinity, depends on the power. This is negative to the 4th power would be positive. So the answer would be a positive infinity. Okay, so it depends on this power and depends on the whether you have x goes to negative infinity or you have x goes to positive infinity. Okay, so this is 3 cases, famous one for the rational function. Degree is the same. You see, if the degree is going to be the same, you just get the number, the result, ratio of the coefficient. If the degree of the bottom one is higher, so this would be 0 all the time. If the degree of the top is higher, you may get a positive infinity or you may get a negative infinity. Okay, so this is limit at infinity for the rational function. I give you a break, we come back. The big one for this group are going to be radical function. So we check that one too, then we are done. So one question, 2 parts, one from each group for this. Okay, so it's a 9:10, 9:20, 9:25 is where we are going to continue. Okay, see you then. Okay, we're going to continue. So that was the first sets of the limit at infinity that you have to know them. Okay, just one case are going to be the one I know, but we use this in future. Now the one is going to be a little bit more challenging are going to be with the radical functions. Okay, so these are going to be this next group. That was part E. Part E is, let's do the part E first. Part E is a special. Okay, this is going to be used all over the places in calculus 2. Okay, this is the only one that, it can be done by those shrinking method, but we don't like to do that one at this level over here. We just want to stay with another theorem. Okay, it's going to be a kind of sine x, cosine x on the top, and this is going to be a power of x down the bottom all the time. Radical x, cube root of x. It's very popular limit for a number of the reasons in calculus. And the way you're going to do it at this level of calculus 1, we just do it by, by using the squeeze theorem. Okay, so the squeeze theorem, remember, so you have to squeeze this function into between two known one. So to get the squeezing inequality, we start with the fact that the sine x is between 1 and -1. Okay, so this is the only solution that's going to be acceptable at the moment. Okay, so we know that the sine x is always between 1 and -1. So it's true also for the cosine. So either one can be handled. Then everything is positive, nothing to worry about because x goes to positive infinity. So you want it divided by x to the 4th. So divide. Divide by x to the 4th minus 1 over x to the 4 less than equal to the sine x over x to the 4. Okay, less than equal to the 1 over x to the 4. No restriction is needed because we are not worried about that x is going to be equal to the 0 because it's infinity. Okay, now we did the job. We shrink it, we squeeze it. So limit of the function to the right to the left, and x goes to infinity. Both of them are pizza problem. So this limit 1 over x to the 4th, x goes to positive infinity would be 0 because the denominator is huge. And this is the same thing. The limit of 1 over x to the 4th, x goes to positive infinity would be 0 too. So by a squeeze theorem, okay, by a squeeze theorem, this limit is 0 all the time. Okay, so this is a very special one. So it doesn't matter really, it's a radical x, as long as there is a power of positive power over here, it can be done. So expect for sine or cosine, both of them can be done with this level. Okay, any question? If you are out of this course in calculus 2, of course, we have a method for this. We accept that the method is sine x, they say over there. It's a bounded function because it's between -1 and 1, and 1 over x to the 4, the limit is 0. So the product of the limit of a bounded function and the function whose limit is 0 is always equal to 0. This is the way we talk about it, but not in calculus 1. Remember, in calculus 1, you have to do it for us, and that's the method that we accepted. Any question? So this is a special. You can't do those shrinking one for this one. And now we continue to the radical one, a more challenging one. So that was the first group. So the second group for the radicals start with A again in this review. So we want to find this one, the limit of x on the top, and you have a radical x squared minus x when x goes to negative infinity. X goes to negative infinity. You see, we use the same method. The top is a polynomial. You shrink it to the leading term, which is x. Down the bottom, we have a radical function. We know that the limit of the radical function, we have to go inside. The limit of the inside is a polynomial. So it shrink it to its leading term, which is x squared. So basically this would be shrink into this part. X on the top, radical x squared on the bottom, okay? So the solution is going to be, have to rewrite it, x radical x squared minus x when x goes to negative infinity. So it's going to be the limit of the top x, the bottom one radical x squared. Now x goes to negative infinity. Remember, limit. Now, the point is about the radical x squared. We already talked about it. Radical x squared is absolute value of x. Okay, we already talked about it, that you know it. In calculus, radical all over the places is not equal to the x, is not equal to the positive negative x, it's equal to the absolute value of x. When x goes to negative infinity. Now you decide what are you going to do with the absolute value. Depends the sign of the x. In this case, x goes to negative infinity. When x goes to negative infinity, x is negative. So the absolute value of x would be negative x. If x goes to positive infinity, x would be positive. This would be x. So this is the only place that you may make a mistake. And you got to be careful. I just explain it here for just your information, that in this problem, x is negative. So I'm going to changing the absolute value of x into the negative x. Okay, so it's going to be equal to the limit of x on the top, negative x on the bottom. X goes to negative infinity. So you cancel it out. The final answer is -1. Okay, make sure you get this one right. So the same problem, if this is going to be given x goes to positive infinity, this would be +1 because use the absolute value of x equal to the positive x. Okay, any question? So just, just make sure don't miss this point. Otherwise, it's a very nice method. The method in your book is, it's complicated, but you get used to these type of methods because you're going to use it in future for sequences and series. Things getting more complicated, you can easily take care of those problems quickly. Okay, that's one case. I'll just give you, we have a couple of them. Just finish all of them, but one of them would be given to you. So part B, a similar one, but the limit is different, 3x minus 2. Okay, 3x minus 2 and the radical x squared plus 1. And your x goes to positive infinity. When they write infinity in this book, they mean positive infinity. Again, same thing, the top polynomial should shrink it to the 3x. The bottom one radical function, we go inside the radical. Inside the radical is a polynomial, we shrink it to the leading term. So the leading term are going to be this part. Okay, so the solution is going to be, we have the, I repeat it, limit of the 3x minus 2 radical x squared plus 1. X goes to infinity. It would be shrinking to the limit of 3x radical x squared. X goes to infinity. Again, radical x squared is the absolute value of x. 3x over the absolute value of x. X goes to infinity. Now again, you see, x goes to positive infinity. So x is positive. This is just for your information. That we say, oh, we talk to ourselves, say, oh, x is positive. So I know that the absolute value of x must be changing to the x. So this limit would be limit of, you can do it right away if you know, when you write it down, you just have a look and do it, we accept it. Okay, so it's going to be x goes to infinity, and the x would disappear, we get the 3. So that gives you 3. Okay, same problem, if x goes to negative infinity, this would be -3. Because you replace the absolute value of x by -x. Okay, so just pay attention to that. It's going to be always the kind of a square root. Any question? The next one is the same. This radical can be on the top, no problem. So the case that the radical is on the top is the limit of, again, you have similar one in your assignment. Just pick a couple of them when you do your assignment of this section, just to practice. You see, the radical is on the top, no big deal. And we can do it. Shrinking part, the bottom one 2x. The top one is, you see, this is going to be the shrinking part. Okay, so solution. Stay with the limit. Remember the limits. You can do this operation as long as the limits is appear. Must be, must be present the limit. So it's going to be the limit of x goes to negative infinity. Now the top would be radical 9x squared, the 2x. So all those big O notation that I introduced for you the other day in computer science, if you like. Now, the big thing is the top again, radical 9x squared, you remove, you take the square root, but you have to use the absolute value again. It's absolute value of 3x. And this is going to be the 2x. X goes to negative infinity. Again, x goes to negative infinity. Since x goes to negative infinity, you drop the absolute value by using the opposite, negative 3x, okay? So again, you just put x less than 0 to remind yourself. So it's going to be limit of, the top would be negative 3x. The bottom one would be 2x. X goes to negative infinity. Simplify the x, negative 3/2. The final answer. Okay, so it doesn't matter where this radical is going to be, the top or the bottom. We can do it. Question? Now, there is only one special case for this group, and that's the case that it's not going to be a rational function, and you have to do a little bit, more operation to do it, and that's the part D. Again, this is the kind of limits that we are not going to use it for the time being, but it's good to know. Let's see what is special about this one. You have, 3, 4 in your assignment. X goes to negative infinity, and you want to find this limit. It's a 3x plus a square root of 9x squared minus x. You see, the difference is this is not a rational function. Okay, it's not going to be a rational function, but let's see. You see, this is a polynomial type and the radical type, or parts. In the case of the polynomial part, you see x goes to negative infinity. Remember, you replace the x by negative infinity. That will give you a negative infinity. In the case of the radical one, you have to go inside the radical. It's a 9x squared leading term. When x goes to negative infinity, that would be positive infinity. So this is, in fact, in short, this is going to be equal to the limit of the first one would be negative infinity, plus the limit of the second one would be a positive infinity. It's two parts, polynomial type part, a radical part. Polynomial part 3x, x is negative infinity. Radical type, because it's a square root, it's going to be always positive infinity. You see negative infinity by positive infinity, we call it indeterminate form. Of course, infinity, not a number, so you cannot cancel them out. You say this is indeterminate form, which means that at this level, in this form, we are not going to be able to determine the results. Okay, this is a no. So what we are going to do, we have to change it. We have to modify it. How are we going to modify it? If it's going to be of this form, a rational function, we can do it. So what we are going to do is we are going to change it to the rational function. How are we going to do it? How are we going to change it to the rational function? You are going to rationalize it. You multiply and divide by its conjugate. Remember, the conjugate means this is positive. We multiply by the 3x minus. Okay, so this is your extra job. It takes a bit more time, but it's not bad. So the solution, you start with the given one, 3x plus the square root of 9x squared minus x. Okay, This is the given. So you rewrite it, limit of x goes to negative infinity, get a fraction bar. You start with the given one, it's a 3x plus radical 9x squared minus x. You multiply by its conjugate, negative 3x minus the square root of 9x squared minus x, okay? And you do the same thing to the bottom, 3x minus radical 9x squared minus x. Okay, you multiply the top and the bottom by the conjugate of the top. Now the top is special FOIL, multiply, remember, the square of the first one minus the square of a second. So it's going to be limit of x goes to negative infinity. The square of the first one, it's a 3x squared minus the square of a second one, 9x squared minus x all squared. And the bottom one would be unchanged. So it's a minus 9x squared minus x. Stay on the top, simplify, it's going to be equal to the limit of. So that gives you 9x squared minus, remove the radical, 9x squared minus x. The bottom one again is unchanged. You see, this is going to be the case. Just keep going to simplify the top. There's a negative here, apply it inside the parentheses. So it's going to be limit of x goes to negative infinity. Now the top is going to be 9x squared minus the 9x squared and the plus x. And the bottom one is a 3x minus the square root of 9x squared minus x. Now these two would cancel out. We arrive at the fraction that's going to be easy to handle. So the top would be x, the bottom one would be 3x minus radical 9x squared minus x. X goes to negative infinity, you see? This is extra action that we have to take to simplify it, to change it to the rational function. Now we can do it. Any question? So you shrink the top into the x. The bottom one, remember, it's two parts. Polynomial, radical. For the polynomial, it would be shrink to the 3x. For the radical, you know that would be shrink to its leading term. So it's going to be equal to limit of x on the top, 3x for the polynomial minus a radical 9x squared when x goes to negative infinity. Okay, remember you have two terms, remember as we did it, limit of the first one plus the second one. So the limit of the first one is shrink to 3x, the second one that's radical. Now simplify the radical as usual. This is going to be x, and this is a 3x minus the square root would be 3x. We have to use the absolute value. X goes to negative infinity. Absolute value, x is negative. When x is negative, this would be negative 3x. So it's equal to, remind yourself that x is negative. So this is going to be limit of the x on the top, 3x minus negative 3x. You see, x goes to negative infinity. So we replace the absolute, then negative would be positive. So that gives you 3x plus 3x, which is a 6x. So that gives a limit of the x on the top, 6x down the bottom. Okay, that's it. X goes to negative infinity. You simplify the x's, the final answer, 1, 6. So, it's a very, very special limit. From operational point of view, it's nice. You do a little bit more algebra to get it, but it's not bad. You are not going to see it as an application, okay, problem in this course. But sometimes there are some functions in application that you may be interested to finding the so-called the asymptote, then you may have to use this type of ideas. That's why, we check it and we leave it for, okay, for future in case we want to use it. And that's it. There is one more. It's very similar. I don't have time for that one because I want to go make sure to get the other two. If I get time, I come back and do it. So one problem of this group of the limits at infinity that I gave you, two types, a rational one and a radical one. Okay. So that will take us to the next topic. Next topic, easy one, but good for future. Remember the tangent line approximation, or we call it linear approximation. We investigated that we can estimate the value of the function by its tangent line, and that will help us to be able to estimate some values. Okay, so this is again the type of that we use in calculus 3, but we would like to keep in mind. We are going to be having a application type. So let me write the problem for you. If I can get it back for myself. So we would like you to, this is number, okay, number 5. We need it for future. Okay, and this is it. We would like you to use a linearization. Use a linear. You have, 4 or 5 of this problem in your assignment. So that's why we checked one, and then you can check it for yourself. Use a linear approximation, or the expression is linearization. Use a linearization, or a linear approximation. Linearization or differential, or differentials to estimate. Okay, to estimate these numbers, a square root of 104. This is one of them, and the other one is a square root of 9.09. I do one of them. If I get time, I come back. Okay, that's it. Remember, we talk about it, that you can estimate the value of the function by its by the tangent line, or you can estimate it by the differential. Now, let's say I'm going to do it. So for this type of problem, you need a function. The function is easy to find. You replace this number by x, that give a radical x. So the function in question is a radical x solution. So you introduce the function. Suppose your function is f of x equal to the radical x. Then you need a point of estimation to estimate this value. You have to pick something which is close to the 104, and it must be a perfect square. If you want to do this one, you have to pick something close to the 909 and a perfect square. Let's try this one. So I'm going to try the radical. Okay, I'm going to do this is the one that I'm going to do first. Okay, so if you want to do it, any suggestion? Give us a number that's close to the 104 and it's a perfect square. Any suggestion? Number?
100.
Number to be close to the 104. Yeah, you are right. 100. We need a number to be perfect square and close to the 104. 100. It must be perfect square. Somebody say, oh, I pick 103. No, 103 is close to, but it's not a perfect square. So we pick that number. Okay, that number, we call it A. I do the linearization first. 100. So this is the way you do it. You are going to find a linear approximation or just a tangent line problem. Around the A, remember the formula L of x equal to I write the formula general one, is f of A plus f prime of A times x minus A. This is linear approximation or linearization. Approximation of f at a, at x equal to a, or just tangent line. A tangent line to the graph of the function at x equal to a. Now you want it at 100. So your formula would be L of x equal to f of 100 plus f prime of 100 times x minus 100. That's your formula. So you need to find what is going to be f of 100, and you need to know what is going to be f prime of 100. Okay, so there you are. Your function is f of x equal to the radical x. So f of 100 is the square root of 100, which is 10. That's f of 100, differentiate f prime of x. F prime of x would be 1 over 2 radical x. So you're going to find that f prime of 100 is a 1 over 2 radical 100, which is going to be 1 over 20. Go back, write the equation of the line, tangent line, or your linearization. So L of x would be f of 100, 10, f prime of 100, 1 over 20, times x minus 100. Simplify it. So that give it 10 plus 1 over 20x minus 100 divided by 20. This would be 5. So it's going to be 10 minus 5. So L of x is going to be equal to the 1 over 20x plus 5. This is the tangent line or linear approximation of your function. So this means the value of the function can be estimated. It's almost like L of x, but if you pick any number close to the 100. You see, that's the idea of the linear approximation. But the number that we're going to be interested in is 104, 104. So it's true for 104. So this means f of 104 is almost like L of 104. F of 104 would be radical the square root of 104, which are interested in, or we are interested in. L of 104 substitute. So that give 1 over 20 times 104 plus 5. Simplify it. Simplified by 2, that gives 52 is a 5.2. 5.2 plus 5, which is 10.2. So we overestimate the square root of 104 must be 10.2. But you have to confirm it. Okay, confirm it by your calculator on the test. So you bring your calculator and you just do it and just write it down for us. Okay. So this is it. A square root of, that's it, the square root of 104. Okay, as you can see, 10,198, which is almost 10.2. But you write this one on the test, exactly the same thing. You show that, you did check it. So calculator, a square root of 104 is going to be 10.198. Okay, a good job, because this is almost 10 up, 10.2. Okay, so this is the notion of the tangent line approximation. It can be done with the differential, but this is easier because I want to make sure that I will be able to check the integration for you. But otherwise, I can do it with the differential as well. Okay, so again, we are not going to use it in this course. But as I told you, it's quite interesting. It's going to be used in science, in application problems. And of course, when the function is going to be a function of two variables or 3 variables, this is the part of the definition of the derivative of the function. Okay, so just pick a function because you have 5 in your book. And so the function is clear, whatever number is given to you, you just replace it by x, that give you the function, pick a point of approximation, something close. For this one, I did it during the lecture, I think. You pick a equal to the 9. Okay, so that would be number 5. I want to make sure that I get enough time to do the number 6 for you, which is a definite integral, and you get 2 questions on this one. Okay, so the idea of the antiderivative or definite integral, remember, this is the opposite operation that we're going to have. So it's a number 6. Number 6, we want to find indefinite integral. Okay, this is going to be find each integral or just each indefinite. You don't have anything else in the moment or at the moment. Indefinite integrals. Remember, in this, the idea is the derivative of the function would be given to you. You would like to find the function. The operation is called antiderivative because the first one was called derivative, or indefinite integral. We give you the formula. The only formula that we need is just kind of the power rule. Okay, this is your formula. Integral of x to the n dx. This means you are interested in a function whose derivative is given to you. Action of integration is opposite of the differentiation. In differentiation, we reduce the power by 1 unit. In this case, we add. So it's going to be x to the power n plus 1. In the case of differentiation, we multiply by the power, now we divide. And we add the constant c because the derivative of c is 0. This can be done all the time except when n is -1. We are going to talk about the -1 later on. So this is power rule. Power rule for integration. You don't need anything else, just this one for the following problems and of course for the application. Okay, so all the other operations are the same as the differentiation that we did. So, you know, if you want to differentiate the radical, you switch the radical. If you want to differentiate anything, a rational function, you just move it up. So it's the same operations. There you are. And we give you 2 problems for this one. 1 problem, 2 parts. And we check radicals, quotients. These are the ones that we are going to be interested in. So the first one is this. You want to find the 10x to the 4th minus 8x to the 5th minus 2 dx. That is the case. Now, you see this is the only formula that you have, a power function. So the first one is fine, we can do it. This is not the power of the function. It's down the denominator, you move it up. So you rewrite the radicals and you rewrite the quotient. So the solution is going to be, you rewrite it, it's going to be 10x to the 4th minus 8x to the -5 minus 2 dx. Now we operate this formula. 10 is a number, coefficient, you keep it. Action of integration, move up the power. X to the 4th, 1 up, 5, divide by 5, you're done. Next, -8 is a coefficient, you keep it. Action of integration, x to the, move up the power. -5 plus 1 would be -4. You divide by -4, done. Minus 2. You see, in case of the number, we can think about it as 2x to the 0. When you move it out, they'll give you x. So this is going to be -2x. Because derivative of 2x is 2. Okay, or this is 2x to the 0. You move up the power, you get a 1. Always you add the constant c because you are going to have many solutions. You have to simplify it. We don't accept any negative power. So if there is going to be negative power, you have to take care of it. But I simplified first. This would give me the 2. So this is going to be 2x to the 5th. Now over here, negative would be positive. So the sign would be positive. And this would be simplified into the 2, but you have to bring this one down. Get a fraction, 2 on the top, x to the 4th on the bottom. Minus 2x plus the constant c, and you're done. So no negative power in your answer. If it's going to be the one, you lose points. Okay, it's going to be very easy operation like the derivative. You know that when we have a coefficient, we keep it. So 10x to the 5/5 minus 8x to the 1 up. Negative, okay. I made a mistake here. I'm sorry. Yeah, that's correct. Move up. Negative 5 plus 1. Negative 5 plus 1, that gives a negative 4/4. And the integral of a 2 is 2x, because the derivative of 2x is 2. And you have to add the constant c to give us all the possible solutions. No negative power in your answer. You bring it down and you're done. Okay, so this is case 1. Any question? You have all these, something with the radical, something with the quotient. So let's do them better. I do it in this order to explain it. I do the d first. D is 2 over cube root of x, okay, plus x cube plus 7. Dx radicals. If you see the radical like in the differentiation, you have to change it because you have only the power rule, nothing else. So it needed to be rewrite radical. You see cube root of x would be cube root of x is x to the 1/3. But it's down the denominator. So you move it up at the same time. So it's going to be 2x to the negative 1/3. Okay, so you have to rewrite it. The denominator cube root of x to the x to the 1/3, you move it up to x to the negative 1/3. And the rest are going to be the same. That's only rewriting. Now action of integration. 2 times x to the negative 1/3 plus 1. We talk about it's like negative 1 plus 3 is going to be 2/3 and divided by 2/3. That's the first one. The rest are easy, plus x up, x to the 4/4, 7x, and the constant c. You have to simplify this one and use the reciprocal to bring this number up. So it's going to be 2 times. Is the 2/3 would be 3/2. X to the 2/3, okay, plus x to the 4/4, and the plus 7x plus c. These two would cancel out. So the final answer, 3x to the 2/3 plus x to the 4/4 plus 7x plus the constant c, and then do that. Okay, so just be careful about these radicals, about this quotient, that you have to move it up to get there now, to get this one through. Any question? Now, there are a couple of just 1 or 2 VIPs of this group, and you have quite a lot in your problem in your book. You better check it for yourself, but this is it. Part B. This is where you make a mistake and you do it on the test, okay? Just let's see. To be careful not to make any mistake. It's going to be 12 plus. And in your book, they like this. They give you quite a lot in your assignment. Again, check. 3x squared over x to the 4th dx. You see this one? You get a little bit more algebra again. So what I'm going to do is, you have to rewrite it, you see, x to the 4th down denominator. You have to move it up. When you move it up, it's going to be x to the -4. When we say move it up, in this case, you have to multiply by everything on the top. Okay, so you move it up and multiply by everything on the top. This is where some people, they missed it. So this is going to be the solution. Rewrite it. You see, move it up means x to the -4. But you must open up the parentheses when you want to multiply it. You see, some people, they don't put these parentheses here. If there is not going to be any parentheses, you multiply this only by the first term, which is not correct. You have to multiply by everything. So you must have a parenthesis, okay? This is the only place that you may miss it. Then you multiply it inside and integrate it. When you multiply inside, when you multiply the same base, you add the exponent. So just make sure don't miss these algebras. So this is going to be equal to, multiply, go forward, 12x to the -4. Repeat it again, plus 5x to the, you see the power -4 plus 1 would be -3. Sorry. And you continue, minus 3x to the -4 plus 2. -4 plus 2 would be -2. -2 dx. You see, that's the way you do it. Any question? I'll talk about the other method the other day that some people, they don't like this method. They break this fraction. They write it down as a 12 over x to the 4, 5x over x to the 4. That's another option. You can do it if you like. But this method is easier. Now we are ready to differentiate it, integrate it, okay? Just make sure, put the parentheses. Make sure you multiply by everything inside, not just the first one. The rest are just standard. We keep the 12 and we add the power x to the -4 plus 1 would be -3 over -3. That's first one. Plus 5 times x to the -3 plus 1. It's a -2 over -2 minus 3 x to the -2 plus 1, -1 over -1, but add the constant c to get the general solutions. Okay, you're not done. You have to take care of all those negative signs one by one. So it's going to be equal to, you see this one, 12 and 3 would be canceled out. So if I can put it over here, it's going to be, okay, it's going to be equal to, you get equal to, there's a negative sign here, so it's going to be negative. I put the fraction. The top is going to be 4, because 12 divided by 3 would be 4. I bring x to the -3 down, x cubed. Okay, you cannot have any negative power in your answer. So 12 divided by -3 would be -4 divided by x cubed. Okay, do the same thing over here. The sign is negative, negative, positive would be negative, so fraction would be minus. Again, 5 on the top, 5 on the top, 2 already, and you bring the x to the -2 down, x squared. So that gives a -5 over 2x squared. Okay, next, negative, positive, positive, you get a fraction bar, 3 on the top, bring x to the -1 down to give you x plus the constant c. So that gives you the final, answer. Any question? So far, this is the only one that, not bad, but it's different. It's the only one that's going to be different from the other one, and you have to pay attention to make sure that you are able, to get through it. Any question? So be careful of the algebra. You move it in, okay, quite a lot. Again, the assignment on that section 4.1, just have a look and do the similar one that you're going to have. You have one more of this group. Again, this is a problem in your book. Sometimes they make it they like more fun for you, and instead of x to the 4, they may give you something like radical x, cube root of x. Not a big deal, but we want to make sure that you can handle it. Okay, so let's check that one too. So that will be part C. So we get one question on this number 6, 2 parts. It's going to be, the part with a couple of fractions and the radical function. Okay, so let's say this is from your book. How you handle it if it's going to be radical down denominator. So it's x plus 1 over radical x dx. Again, you see, you can't do anything about it as is. So what we have to do is we have to take the denominator. We have the radical here, so we change it first into the x to the half. So let's do it in 2 steps. So it's going to be x plus 1 on the top. Then we have x to the half here, dx. Now you have to bring x to the half up. As I talk about it, you bring it up. You call it x to the negative 1/2. But open up the parentheses. Again, that parentheses shouldn't be missed. Any question? Multiply across and just integrate. So it's going to be integral of x to the, add the powers. Negative 1/2 plus 1 would be positive 1/2. Plus x to the negative half times 1 would be x to the negative half. That's it. You see? So nothing about worry about, they can make it, cube root of x, cube root of x squared. It's not a big deal. We can do it. And you have to be careful. A parentheses and now just add the power. It's going to be x to the 1/2 plus 1. It's like 1 plus 2, 3/2 over the 3/2. Okay, plus x to the negative 1/2 plus 1. It's positive 1/2. It's like negative 1 plus 2. It's going to be 1/2 over the 1/2 plus c. Use the reciprocal of this number. So 3/2 would be 2/3. 2/3. Okay. Is going to be 2/3 of the x to the 3/2. Use the reciprocal of 1/2 would be 2. So that gives it 2x to the 1/2 plus the constant c, the final answer. Okay, so we can handle all sorts of, type of integration so far nicely. Any question? So this is going to be the first group of these problems. Now we talk about the kind of applications. The application is that we can solve so-called differential equation. So the derivative of the function would be given. Derivative is rate of change, its velocity. You see, if object is moving, if you know the velocity of the object, then you can locate it, if you like, with the integration, which is very important. And then there is this c that we talk about. When you add the c, means we can replace c by any number you like. C plus 1, 2, 3, negative 1, negative 1/2, because derivative is 0. But sometimes you'll be interested in a special solution. You need one of these. If you need it, you should give us an address. You should give us one condition of the function so that we'll be able to find the c. So this would form a kind of application format that it's the same problem, but with a different interpretation for future. And that would make our last problem. So you get one problem on these 2 parts. And again, we change it to the format of a Cauchy differential equation so that you'll be able to find the c for us. Okay, that would be the idea of number 7. So we get 1 on 7 with 2 parts. Since we don't want to use the expression of a differential equation, sometimes we give you this instruction. Would like you to find, that's the instruction of the function, find a function. Find a function y equal to the f of x that satisfies that satisfies the following condition. Following conditions. Or basically, sometimes we say it's a solve each differential. Okay, each differential equation, which is the same thing. For future, it's going to be all differential equation. We talk about an equation that contains, those differential, and the way they are going to express it is in differential form. That's it, part one. dy dx is equal to the 8x cubed minus 4x minus 1 with the condition that f of 0 is equal to 1. Now, this means when you find that there's going to be a c, then you have to find that c for us. Okay, so this is a kind of application type. You see, you are going to replace this one by y prime or f prime. That would be familiar notation. Then f prime is given to you. You want to find the f, you have to find the antiderivative or just the integral. Okay, so the solution, you rewrite it, f prime is equal to the 8x cubed minus 4x minus 1. So you have the f prime, you want to find the f, you have to go to the past, integrate it. So by the definition, f of x would be integral of 8x cubed minus 4x minus 1 dx. That's it. So you have to put it into this concept of the integration yourself, according to the definition that we have. The rest are easy. There is no radical, no rational expression, just integrate. 8 is a number, move the power up, x to the 4th over 4. Minus 4, move the power up, x squared over 2. Negative 1 would be negative 1x, which is a negative x. That's c. You want the function whose derivative is negative 1. That function is negative x. You simplify. So f of x is equal to, see this 2 would cancel out, that give you 2. That give you 2. So the function would be 2x to the 4th minus 2x squared minus x plus c. You see, this is the one we refer to as the general solution, just for your information. When you solve the differential equation, we call this one the general solution, means many solutions. But you'll be given the second condition, f of 0 equal to the 0. You are interested in one of these functions. Which one? The one with this information. We say, oh, but f of 0 is equal to the 1. So this means you go to this equation, you plug in x equal to the 0, and you let it to be equal to 1. If you put equal to 0, 0, 0, 0, it's going to be 0 plus c must be 1. So c is 1. So the function in question is f of x equal to 2x to the 4th minus 2x squared plus minus x plus 1. So this would be so-called particular solutions. This is the way we are going to use it in science. Okay, f prime is rate of change. You can have a rate of change of the revenue, costs, etc. Or in this case, velocity. So we were able to find the function. Okay, so it's the same operation, but a different interpretation for future. Again, there are going to be two types. This is the straightforward one. You may have some fractions. So this is the last one. Try to do it so that we have all the possibilities. Okay, any question? Let's do the last part. And let's see if I can do it before my next class. This is just with the fractional part. So you'll be given one with the two parts. So that's a part B of the same idea. You want to find the function who satisfy this condition this time. Is a 1 minus 2 over x squared, okay, plus 5 over x cubed. Condition is f of -1 equal to 2. It's a fractional one, otherwise the same thing. Again, you have quite a lot in your book. Of course, the one in your book are very easy. You know, the functions are very easy to handle, but it's not bad. Just check them. Okay, again, you don't like this notation, change it to the f prime and then integrate. You can stay with this one if you like. So write f prime is 1 minus 2 over x squared plus 5 over x cubed. That's it. So you have the derivative of the function. You want to get the function. This is antiderivative operation. So f of x would be, you're going to the past, integral 1 minus 2x squared plus 5 over x cubed dx, you see? So quickly you set it up yourself into the case of the integration. You want to integrate it, of course, they are done in the denominator. You move them up and you integrate. 1 minus 2x to the -2 plus 5x to the -3 dx. Now integrate. So f of x is equal to integral of 1 is x. You want a function whose derivative is 1. Minus 2, add x to the -2 plus 1, -1 over -1, plus 5, x to the -3 plus 1, -2 over -2, and the constancy. You have to simplify those negative down the denominator and the negative of the power. So f of x would be x, negative, negative, positive, fraction bar, 2 on the top. You bring the x down. Okay, next, positive, negative, negative, fraction, 5 on the top, 2x squared on the bottom, plus the constancy. This is again the general solution. Okay, but we have an initial condition. So we have to continue. If you don't have initial condition, you're done. But they give you the initial one. So this means plug in x equal to the -1, then let it be equal to 2. Put the -1 for x, -1, 2 over -1, minus 5, 2 times the -1 squared, plus c, equal to 2. Okay, that's f of -1. Simplify, this is going to be -1 minus 2. -1 squared would be just a positive one, so that give minus 5/2 plus c equal to 2. Okay, so for c, this is going to be -3 minus 5/2 plus c equal to 2. So your c would be, so c would be 2 plus 3 plus 5/2. That give you 5 plus 5/2, which is going to be 10 plus 5, 15/2. Okay, so c is 15/2. You have to go and give us the function. So the function or the solution is x plus 2 over x minus 5 over 2x squared plus c. What is c? 15/2. Okay, so that was 2.5, 7.5. Yeah, that's correct. So that gives you the final answer. Okay, so we have all these collections together, and it's a very nice one. That's it. Any question? Read this one carefully before starting your quiz. Okay, and that 5 questions. Keep all these solutions because we are not going to review it again for the next test. you know that it's going to be repeated on your next test again. So this 5 question and the 6 question, the new one, 6 and 5, 11 would be test 3. And whatever we do on test 3 would be repeated on the final. Just make sure don't miss test 3. It's very, very important test. Okay. So, and that's it. Have a good one. And I'll pick up your test today and then start grading it. So you see your grade over the weekend. Okay, when I grade it, when I'm done, then okay, I'll post the solution to that one. We can compare it together. And then if you feel, you know, you need anything, you need explain, you have to email me, then we're just talking about it. Okay, take care and just check the quiz.
Thank you.
By tomorrow. Okay, have a good one. If you need anything, just let me know.